This is the second day of sections 9.4 and 9.5. We're still talking about trigonometry. So we're going to talk about word problems today. And there are two words that we're going to, or two phrases we're going to use, angle of elevation and angle of depression, when they're describing a word problem. Angle of elevation is described as when you're looking up at something. So from whatever the viewpoint is to the top of an object would be the angle of elevation. So essentially, in a triangle, a right triangle, the bottom angle would be the angle of elevation. The angle of depression is if you're looking down at something, and the angle of depression really happens outside of the triangle. So the triangle is really happening down here, but we're looking down from a horizontal line as the angle of depression. What's really nice is the angle of depression and the angle of elevation are always congruent to each other. So if they tell you what the angle of depression is, you can just treat it as if it was the angle of elevation and put it as the bottom angle. The only time we would ever really use the upper angle in the right triangle is if they're literally describing the angle formed by the vertical object and the diagonal object. It's not going to happen very often. When we get a word problem that's used one of these words, we're going to have to usually draw a picture to represent our problem. If they give us a vertical distance or a height, that would be the height of the triangle. The horizontal distance is always on the bottom. We know the angle of elevation will be in the bottom corner. If you wanted to put the angle of depression in, that would have been up here. But remember, it's congruent to the angle of elevation. And then if they're describing an object that was leaning up against something, that's usually the diagonal line. And that is sometimes what we will be given or have to find. So if we had a ladder, say, and we knew how long the ladder was, that would have been this measurement here. There's no real descriptor to put there for it, like we have horizontal distance and vertical distance. It's going to be a different kind of thing for each problem. So let's look at our first example. We know we're going to have to draw a right triangle every time, so I'm always going to start out by drawing one. Casey sights the top of an 84-foot tall lighthouse at an angle of elevation of 58 degrees. So there's two things in here. Angle of elevation is 58 degrees. The angle of elevation always goes in the bottom corner. And if it's talking about how tall something is, that would be the height. That would be 84 feet over here. How far are they standing from the base of the lighthouse? So the bottom of the lighthouse is here. They're standing where the angle of elevation is, so we're looking for the horizontal distance. Now the problem becomes like one of the regular SOHCAHTOA problems. We're going to circle our angle. We're going to label O for opposite, A for adjacent. O and A, the combination is tangent. So tangent 58 is equal to 84 over X, O over A. Because the variables on the bottom, numbers on top, we're going to end up using division. So X equals 84 divided by the tangent of 58. And on our handy dandy calculator, we would do 84 divided by tangent 58. And we would get 52.5. Okay, let's look at example 1B. A lifeguard is sitting on a platform looking down at a swimmer in the water. If the lifeguard's line of sight is 8 feet above the ground and the angle of depression to the swimmer is 18 degrees, how far away is the swimmer from the lifeguard? So we have our right triangle. We have a platform 8 feet above the ground, so 8 feet high. We have an angle of depression of 18 degrees, which would be the same as an angle of elevation of 18 degrees. And if this is where the swimmer was, and this is where the lifeguard was, and I want to know how far away they are, we can find this distance. Using the 18-degree angle, we have O and we have H. So O and H is sine 18 equals O over H. That's going to be 8 over X. the numbers on top, so we're going to end up using division. 8 divided by the sine of 18, and we get 25.9. Some more examples together. We have Leah's mom is standing at the bottom of the slide at the playground, waiting for Leah to slide down. The angle of elevation from the bottom of the slide to the top is 46 degrees, and the slide has a vertical height of 9 feet. Find the length of the slide. So in our right triangle, we know it has a vertical height of 9 feet, an angle of elevation of 46 degrees, and they're asking the length of the slide. Now, if you're going to slide down the slide, you would be sliding down here. So that will have to be our variable. So we have again O and H. So we're going to use sine 46 equals 9 over x. 9's on top, so we're going to use division. 9 divided by sine 46. And now we get 12.5. So we're going to say 12.5 feet. The last one for us to try together. A wire is attached from the top of a 30-foot tall telephone pole to a stake in the ground. If the angle formed by the wire and the pole is 48 degrees, what is the length of the wire? So this is our pole, and the pole is 30 feet tall. The angle is formed by the pole and by the wire. So this is one of our rare instances where the angle we're creating is up here. And it's asking what is the length of the wire. This side of the triangle was the wire, so that's our variable. So using this angle, we have A and H. So A and H is cosine, and A over H would be 30 over X. Yet another division problem. We're going to do 30 divided by the cosine of 48. And that would be 44.8 feet. The final two problems are both check-ins. You can pause between them, or you can finish the lesson. That's the first check-in, and here's our second check-in. Answers are posted on Google Classroom, but that is the end of our word problems for 9.4 and 9.5.